All right. Today we are looking at financial models, and so we are looking at ways to solve equations based upon money. There are two basic financial models which are basically the same thing. One is just an extreme version of the other, and that right here is this lovely formula right here. The amount of money, the amount of money that you have at the end is based upon the amount that you start with multiplied by the growth of that money. And that right here is a formula that tells us how much money we have in the bank. This is what we call have normal compounding. So we have normal compounding right here. And compounding is simply how many times you get paid interest. So if you have if you're compounding every month, you get 12 interest payments. And so therefore your number of compounds would be 12. And so we call P the principal. That is the amount of money you are investing. R is the annual interest rate. As a decimal, not a percentage. T is the time in years. N is the number of compounds. Again, this just refers to how many times you get paid interest in a year. So let's say you have a bank account and the bank account pays you interest at the end of the month. Then you're going to get interest payments 12, so N is going to be 12. It's the number of times the money grows in a year. If you have a bond and the bond pays you every 4 months, every 3 months, that is quarterly, then there are 4 quarters in a year, so N will be 4. Daily is 365, weekly is 52 weeks in a year, annually obviously is 1 if you're doing it only once a year. There's biannually or semi-annually, and that's twice. And of course, A is the accumulated amount, what we sometimes call a future value. How much money you will have at the end of the period. Now, sometimes we have an extreme form of compounding, which is called continuous compounding. In continuous compounding, they're always paying you interest every instant of every day. And when you have that right here, you have to use a different formula, and that formula is A is equals to P E natural number RT. Remember I mentioned that the natural number is the most important number. This is like one of the first times where we see it appears. And it basically says that this is the fastest rate at which money can grow. All the names are the same. Notice, however, that there is no N in this formula. No N in this formula right here, because compounding continuously technically means N is infinity. And so the formula simplifies once N pushes out to infinity. So let's look at 3 questions, and we'll do the 2 questions from 2 perspectives, one from normal compounding and one from continuous compounding, to get a feel of how much more money you get if you're always compounding as opposed to sometimes compounding. And so first question, how much money will you have after 4 years if you invest $2,000 at a rate of 7%, compounded monthly and then compounded continuously? So how much money will you have after 4 years if you invest, so that's how much you're investing is your principal, $2,000 at a rate of 7%. Now we will not use the 7%, instead we will use the 0.07. We always use the decimal in our calculations. Now if we are compounding monthly, that will tell us that N is equals to 12, and we just plug these 5 numbers into the formula and solve for the amount we have. So A will be 2,000 multiplied by 1 plus the interest rate divided by the number of compounds raised to the 4 multiplied by 12 times number of compounds. All you need is a calculator to get this answer. If you don't have a calculator, this is the answer. You can simplify the 12 and the 4 and make that a 48. But that right here is something that you don't have to. And so your answer is going to be $2,644.11. And 11 cents. On the other hand, if I'm compounding continuously, there is no need for n, and I just use the formula, which is, and then I just use the formula, which is 2,000 multiplied by e raised to the 0.07 times times the time, which is 4 years, and then you simply plug that into your calculator and work it out. And once you work that out, you get $2,646.30.